Hello guys, welcome to the mathematics lesson. In today's mathematics lesson, we will be looking at the mathematics lesson 1 on computers. Okay, so you must understand that there is a topic in mathematics which deals with the computers. All right, so that is the one that we are going to look at, and this is lesson number 1. All right, so without further ado, let's just get straight into the lesson. So we'll start with the definition of a computer. So you need to know, guys, that a computer is an electronic device that can accept, process, store, and output data. Yeah. So a computer, as the English here is able to say, this is a simple English, guys. As a grade 12, you must have developed your English to a certain standard that simple sentences like this, they don't need you, or they don't need much explanation for you to understand, because there is nothing actually to explain here. It's just that we are telling you that a computer is an electronic device that can accept, okay, process, store, and output data. That is it. That is it. So nothing to explain here. So that's what a computer does. It accepts data, then processes that data. It can store that data or output the same data. All right, so let's look at the basic processes of a computer. So we are saying the basic processes of a computer are, we have number 1, input is a basic process of a computer. 2, processing is the basic process of a computer. Then 3, output, and the store. So in the processes that a computer does, it either do the input, or rather accept the inputs, then processes that the input here, and then it outputs that information or store it. So these are the basic processes of a computer. All right, so let's look at what input is. We are saying input, this is the process of taking data and instruction from a user or another device into the computer. So input is just the process of getting data either from a paper or from anywhere else, and then putting it into the computer, so that information which is put in the computer can be said to be input, or that process of putting information in the computer can be said to be input, that process itself. All right, so what devices do we use to put information into the computer? So we are saying keyboard, mouse, joystick, webcam, microphone, scanner, etc. are examples of input devices. Okay, so keyboard, mouse, we have a joystick. So joystick are just some of the flash disks, if not mistaken, which we can put to the computer here. So the keyboard, the mouse, joystick, webcam, microphone, scanners, etc. are examples of input devices. So these devices are used to send data and instruction to the computer from a user or another device. Yeah, so that's what you should know when you hear of input devices. These are the ones that you use to do what, to put information into the computer. Then we move to processing. So we are saying this is the processing, or this is the process of manipulating the input data according to the instructions using the CPU and other programs here. So let's say you have put information here. Then that information that has been put into the computer, it has to go to the next level of processing. Okay, so in the level of processing, what happens is that the computer does some manipulation, or it does some processes on that information. All right, and how does it do it? According to instructions that is needed. Okay, so let's say you are just typing a letter. So as you punch on the keyboard, the computer will just understand, oh, this person is just punching the letters. Okay, that is manipulation. So it will just change the information that is on the keyboard, which is in electrical form, then it displays it on the screen the letter the way it is. So it has just manipulated like that. Now if you are doing a calculation like 4 times 3, so the computer will now process. If you say 4, then you say times, then 3, then you say equals. So the job of the computer, it is to process. So in that process, it will multiply 3 times 2 to get 6. So that multiplication is an example of manipulating. Okay, so don't again be shocked by such simple terms as a grade 12 like this, manipulating. No, 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 no. That means you haven't been doing a lot, because as a grade 12, you must have read a lot of books and your vocabulary must have increased, okay, or grown. Okay, so if that you have not been doing, then it is very, very unfair to you, because you are not going to grow, because certain terms don't need for teachers to explain them to you, because if they need teachers to explain them to you, then they will have a lot of terms to be explaining to you, and if they don't do that, then you are not going to understand. Of course, no teacher, you are not going to find a teacher that will explain each and every term, because if they do that, it means that the learning process is going to be delayed. They cannot finish the syllabus. If they go to teach, then they start explaining words. That is, you have to take it upon yourself to ensure that you know words by yourself through studying, reading a lot of novels, then going to the dictionary to see the meanings of certain words. Okay, but if at this time around you have not done that, then it is too late, because it is not possible that you can catch up with the terminologies. Yeah, so processing, we are saying this is the process of manipulating the input data according to the instructions using the CPU and other components. So CPU, which is the central processing unit, RAM, which is random access memory, GPU, which is graphic key processing unit, etc., are examples of processing devices here. So the devices in a computer that does the processing are the central processing unit, the random access memory, which is the RAM, the graphic processing unit, which is the GPU. Okay, so these devices are used to manipulate data and instructions according to the program logic and produce output. So this is what these do. They do what? They process or manipulate the data according to some instructions that is needed to be done at that particular time or to that particular data. Okay, and then output or produce the output of that particular process. Okay, then output, what is this? We are saying this is the process of sending the processed data to a user or another device. Yeah, so once data has been processed, it has now to be sent to the user. Okay, so that the user can know now, oh, data has now been processed. Okay, if you do 4 times 3 equals, then the answer should be 12. So the computer should display that information on the screen. So the process of displaying that information on the screen is what we call output. It has given out, or it has done the output. So output is the process of sending the processed data to a user or another device. So we are saying that monitor, printer, speaker, projector, etc. are examples of output devices. Yeah, so the monitor, like the screen, the printer, the speaker, the projector, etc. are examples of what? Of output devices. So these are the ones that helps us to see what the computer has processed. So these devices are used to display or deliver the processed data to a user or another device. Then also storage. So what is storage? Here we are saying this is the process of saving the input data and instructions in the memory of the computer for later use. Yeah. So a computer does a lot of things. So that input information can also be saved in the computer for later use, or any output information can be saved in the computer for later use. Okay, so the saving of that information in the computer is what we call storage. Okay, so hard drive, solid state drive, USB drive, memory card, etc. are examples of storage devices here. So in the computer or in computer systems, the hard drive, solid state drive, USB drive, memory card, etc. are examples of storage devices. So these devices are used to store data and instructions in the computer for later use. All right, so the following diagram shows a summary of the basic processes of a computer here. So here a computer should do the input. After it receives the input, the computer should process that input. So processing of the input, then it should do what? It should output that processing. Then it can even store the processed information. So take it to storage. So input, after processing, the information can be given to or can be taken for storage or can be taken to output devices such as the screen, the printer, and the speakers and other things that play the role as the output devices. All right, so now let's look at the computer algorithms, which is very, very now cardinal. This is what now you are going to be finding mostly in exam questions. This part now we are looking at. So the first part that we have done is just to introduce you to some of the concepts on computers, which will help you to understand what we are now studying now. So we are starting with computer algorithms. So what is a computer algorithm? We are saying a computer algorithm is a set of instructions or rules that tells a computer how to solve a specific problem or perform a certain task. Yeah. So a computer algorithm is a set of instructions. So a computer when you punch 4 times 3 equals 6. So a computer has been given instruction that recognizes how to calculate 3 times 4. So that set of instruction that is used to solve that question, you have put 3 times 4 equals 12. That set of instruction or program is what we call computer algorithm. Okay, so computer algorithm is a set of instructions or rules that tells a computer how to solve a specific problem or perform a certain task. So we are saying an algorithm is a set of logical steps. Okay, so this is another definition. If this one is hard, I'm saying an algorithm is a set of logical steps that need to be followed in order to solve a problem here. So it is just a set of also logical steps. Step 1, step 2, step 3. For instance, when you want to cook onshima, what steps are there to be followed for someone to successfully cook onshima? So those steps which are there for someone to successfully cook onshima, those can also be said to be algorithm. So algorithm is a set of logical steps that need to be followed in order to solve a problem. So algorithms can be written in different ways, such as flowcharts and pseudocode. Yeah. So there are many ways of writing algorithm, but at grade level in mathematics, we are going to write algorithm in form of flowchart and pseudocode. All right, so algorithms can be written in different ways, such as flowcharts and the pseudocode. So let's look at flowcharts. What are flowcharts? So we're saying these are diagrams that use symbols and arrows to show the steps and logic to be followed in order to solve a problem. Yeah. So now here, when you want to show the steps to carry out in order to solve a problem, now here you use diagrams. Okay, so when you're using diagram now to show how or to show the steps that should be carried out to solve a problem, then that will result into flowcharts. So that's why we're saying these are diagrams that use symbols and arrows to show the steps and the logic to be followed in order to solve a problem. Okay, so to construct a flowchart, one needs firstly to master. Okay, one needs to firstly master the symbols used in the and their meaning. Yeah. So if you want to construct these flowcharts I'm talking about, so you need to master the symbols used and their meaning. To master meaning, you memorize them in your brain. When you see this symbol, you know what it means. When you see this symbol, you know what it means. Unfortunately, most people and learners have seen that they don't want to memorize that, and that's where their problem is. That's why they're finding it hard to solve specific question, or most of the questions they're failing to solve them because they don't have the ability, or they are not willing to memorize things. They think maybe it is magic that is going to solve things. Never. They need individually to memorize things. Like I'm saying here, you need to master the symbols that are used in flowcharts for you to construct the flowcharts. So those symbols and their meaning, you need to know them. Okay, so let's look at basic flowcharts symbols. So the following are the basic flowchart symbols and their meanings. Okay, so we'll have this symbol here. So this symbol here, another symbol here, another symbol here, another one here. So we will have meaning here. So what does this symbol mean here? This is an oval. When you look at this, it is an oval. It's not a circle, it is oval. So what does an oval mean in flowchart? So the symbol oval means begin or start, or begin or end, or start or stop. Okay, begin slash end, or start slash stop. That's what the oval mean here. Then this one here, it is a parallelogram. So a parallelogram is a symbol in flowchart which means input slash output, or enter slash display. So here, when I use slash, it just means or. I'm just saying slash to avoid this or here. So you can say this can mean input, or it can mean output. So input goes with output, or if you have used enter, if it means, it can mean enter or display. Okay, that's what it can mean. Now this one, which is a rectangular, so a rectangular here means processing. Then here we have should be a rhombus or diamond. So this one means decision. Okay, this is a decision. Then this one just means program flow. Now let me explain a little bit here. So a computer, if you are to use a computer, you need a certain, any program that you need to use of a computer, you need to open it. Okay, so this start here, this symbol here, which represents begin or end or start, this one, it just signifies the opening of a program. For instance, if you want to use a calculator on your phone, you need to go to that calculator and press on it. So this is what it means, like you have pressed it and it is open. Okay, so this is what it means, begin. And after you have finished using like a computer or even a calculator that you have, a scientific calculator, not the one on your computer or on your phone, the physical one which you have, it has that button for switching on and off. So that button can also mean this. You switch it on, all right, which means you have started the begin or start. Then after you have used it, what do? You switch off. It means you have done end or stop. Then this one here, which is the parallelogram, it stands for input, like it means the keyboard. If you want to use your calculator now to calculate something, you need to start punching the numbers. So now this is what it means. The input, it's this one here. That stands for like the keyboard, like it stands for all those input devices that we talked about earlier on. So then this one, it stands for process, like the CPU. The information goes to the CPU, like the CPU, to be processed, okay, to be looked at, to say, oh, what set of instructions should be followed here. In short, here you go for instructions, process or instruction. When information has entered, then it will go to a program or an instruction that will look at it and decide what should we do on this one here. After realizing what should be done, then it processes that information. Then this one, the diamond, it is a decision. If it has to think more, if there are more processes to be done about what information has come in, then the thinking will be done to make a decision if there are more than two decisions to be made. Okay, so you need to have a decision here. Then this one, it is just the arrow which shows the program flow. Now you will understand this, but it is important that you memorize. This stands for either this stands for either this either stands for this stands for this stands for this. This is what we mean to master and memorize. If you refuse to memorize, that is your fault. You'll never know. Okay, so we move. So let's look at examples on how the flowchart works. So we have this question which says, write a flowchart to show how to add two numbers A and B and display them. Okay, so we have a question which is asking us to write flowchart. A flowchart. What should a flowchart do? A flowchart should show how to add two numbers A and B and then display them. Okay, so let's look at the solution now. What I'm going to write here are the stages that need to be in a mind of a person thinking what should they do. But it's not the flowchart. A flowchart, I'll show it here. So the first step to answer this question, you need to start the program, right? Like if it's a calculator, you switch it on, you start the program. Then next, you enter the numbers A and B. Okay, that's what you need to do, right? So after you enter those numbers A and B, two numbers, then what happens? Calculate the sum of A and B. So meaning after you enter them, the calculator now will do what? Will calculate. Then after it does the calculation, what happens? Display the sum on the screen. It will show the sum or the addition of those two numbers. Okay, now this is where the problem is. If I don't mention the word addition to some who have not upgraded their understanding of English, when I just use the word sum, oh, they are lost. That is very, very sad. Okay, so if we say calculate the sum, it means the sum means 1 plus 1, 2. So the result of that 1 plus 1 is the sum. Or find the sum of 1 and 2. It means add 1 plus 2. But it seems these days like learners, they don't want to learn. I don't know what they want in life. And then they are finding like things are hard, yet things are not hard. It is themselves that are unteachable. So display the sum on the screen. So these are the stages of the program that are taken. But when I write this myself here, I am a teacher, I am teaching, meaning you yourself, when you have been given this question here, either you write it on a rough paper like this to follow, or you don't. If you have the ability, just straight into writing the flowchart. So here is the flowchart. So the program is represented by the over. So there will be the last part, which is stop the program. So you start, there will be also stop the program here. So the first thing here, it is to have this over thing, which starts for start. You write start there. Then where you enter, the one I said like the keyboard, it is this parallelogram here. So you say enter A and B. Those are the numbers that will be entered, A and B, on a flowchart. That's how you put it. Then this one, like calculate sum of A and B. So on the calculation here, that's where I said that is the processing is done. And the processing is represented by this rectangle here. So in the processing, there will be sum of A and B. So the processing is sum, which is A plus B, is what to be processed. When it enters there in the computer will say enter A and B. So if you are saying sum, so you enter, it will know, oh, we are adding. So sum is A plus B here. Okay, then it display the sum on the screen. So the display, which is like the screen, is the same as this one here. So it will have this one here. So it will display sum. So this one displays sum. The sum will be shown after it has been processed. Then there will be end of the program, end here, or stop. So the program will stop. So this is the flowchart now. So this was just a guide, as I stated, on to area on to guide. So you put the arrow there to show the flow of the program, that it is from the start to the end. So this is how you can write a flowchart for a question like this one here. So this is the answer here, not this one here. The answer is this one. Then we go to another example which says write a flowchart to show how to solve the surface area of a cylinder given the radius r, length l of the cylinder. The formula of here should have been okay, and the formula for surface area, which is S is equal to pi RL. Okay, so it is very important you understand what the question is saying. It's saying write a flow chart to show how to solve the surface area. Okay, so the flow chart that you should write should show how to solve the surface area of a cylinder. Now they've given you information to use, given the radius r, length l of the cylinder, and the formula for surface area S is equal to pi r l. Okay, so this becomes like an instruction which the computer will use. So again, solution. Again, I'm writing the steps that you should be able to do. So like there will be start the program, then enter the radius, which you should enter the radius and there. So enter radius and length of the cylinder, then calculate the surface area S using the formula S is equal to this one here. Then display the surface area on the screen S, then stop the program. Okay, so these are the steps that a computer does to follow, or you follow yourself when you are even using a calculator. Those are the things you actually do. So in writing the flowchart, you start with this, which stands for start. Then from there, you go to the one for entering. So the entering information like enter radius, you use this one here, the parallelogram. So you just say enter R and L. That's how you do. You just say enter R, L here. Then next, it will go to this calculating the surface. So it is this one which does the processing. So here you enter the processing will be, they will use this here. So enter pi. Now here pi rs, there is multiplication in between. So there's pi times r times l. So multiplication sign in computer language is represented by such kind of a symbol, like a star like that. Okay, so that is a kind of a symbol which is used to represent multiplication. So that's how you say now here AC, which is surface area, is equal to pi times r times L. Then you go to display. Display is the same as enter the symbol. So it is this one here. So you say display S. So display S because S is the surface area. The next is stop. Stop is the same as that. So you say stop. Then you connect them like that to show the flow of the program. Then next you move to the next example, which says the tax rate for any income above 300 kwacha is 30%, while the tax rate for any income below 300 kwacha is 0%. Write a flowchart to show how to calculate tax for given income. Okay, so here, what is there is actually something which I feel like is a little bit hard, knowing the kind of learners we have these days, but yeah, they can't really understand what is going on, what tax is. Yeah, so that again is because maybe someone has not understood how to read very much. Yeah, that is could be the problem, because mathematics is not teaching about taxes, unfortunately. But yeah, there's a topic on commercial arithmetic which talks about taxes here. Hope someone can understand from there how tax is calculated, because failure to know that will make this question like very hard, because if you can't understand the question, then how can you solve it? So the tax rate of any income is 300. Above 300 is 30%, while the tax rate for any income below 300 is 0%. So write a flowchart to show how to calculate tax for given income. So solution. So there will be like, again, step 1, start the program. Then step 2, input the income from the user. So income, what income does the user have? So then 3, you have to make a decision now. If the income is greater than 300, or check if the income is greater than 300. If yes, calculate the tax as 30% of the excess income over 300. If no, set the tax to 0. Yeah. So this is what actually I was saying, that this information here will be hard, because maybe someone, their understanding level has gone shallow. Okay, because they have decided not to do anything, not to read a lot of things. They have decided to make it shallow. No one can make it above or high, unless an individual decides to say, oh, my understanding is shallow, let me read a lot of things. Yeah. Because no teacher can be entering into each and every pupil's mind to see that they are shallow and then start making them to be up. It is not possible, guys. It's not possible. It's an individual to up their game. So why have I put this like this? If the income is greater than 300, if yes, or check if the income is greater than 300. If yes, calculate the tax as 30% of the excess income over 300. Now, this is because they have been given us two conditions. They are saying the tax rate is 30% of any income which is above 300 kwacha. Okay? And they are saying the tax rate is 0 for any income below 300 kwacha. Okay? But the question is saying we should calculate tax for any. So meaning, if we are calculating tax for any given income, it means if someone comes and tell us, oh, my income is 200 kwacha, for us to be able to write a program or a flowchart, we need to say, oh, is that 200 kwacha below what? Below 300? If it is yes, meaning we will not apply the 30% income, tax rate. We will apply the what? The 0%. So if someone comes and says, oh, my income is 400, we'll check 400 kwacha, we'll check. Or is 400 kwacha above 300? Yes. If it is, then we'll apply this, because 30% is the tax rate for any income above 300 kwacha. Then we'll apply that. That's how we will be able to make a program. See the understanding which is needed. Oh, this is why people usually don't like this or this topic in mathematics, because it requires high thinking. Okay, so here, check if the income is greater than 300. If yes, calculate the tax as 30% of the excess income over 300. If no, set the income or set the tax to 0, meaning if that person's income is less than 300, then there will be no tax. They'll have no tax rate applied to them. Okay, they will not be taxed. That's what it means. If no, set the tax to 0. Yeah. Then what will happen is, then output the tax on the screen. Then what? Stop the program. Yeah. So now in putting a flowchart, you start with start, always that. Then the next, you go to input the income. So here in this, you say enter income. You can either say input income or enter income. Then here you see that there will be a decision which will be made. So if there will be a decision, we'll use that one, a rhombus or the diamond here, which is needed to make a decision. So here now, you are going to put a question here. We put a question like, is income less than 30 or less than 300, that's how it is going to be put. If yes, then you put here, you are going to process tax is equal to 0. If no, then you say you are going again to process, you say tax is now going to be 0.3, which is this one here. 0.3 is actually 30%. 30% means 30 over 100. So 30% is 30 over 100, which will give you 0.3. Then it times the income that will be taxed. The amount which is able to be taxed is, if I said, oh, me, I get 400 kwacha, that is my salary. Then I should say, okay, my income, which is 400, minus what? Minus 300, I will remain with 100. Then 100 times this, it will be the tax that I'm going to be taxed on my salary. That's how actually tax is calculated. So then, if no, then they'll say, okay, tax on that person, calculate it using this formula here. Then what else happens? Output the tax on the screen. So the tax will be now displayed on the screen. Display tax. Then what follows? Stop. Okay. So now we'll write a program like that, the arrows. So there'll be an arrow which goes there, an arrow which comes here, which comes here, which comes here. But here again, since this will need also to be displayed on a screen, so this one should be connected here so that it should be displayed also on the screen. Okay, so this is a program for this question. Okay, so now this is your task also. So the task says, in the answer space below is an incomplete flowchart here. So in the answer space below is an incomplete flowchart for calculating the volume of V of a cone. Given the radius R and height h of the cone, complete the flowchart. So this is the formula. So this question came this way in mathematics paper 1 for GCE. Yeah. So this is the question that you need to do, guys. For those interested in online lesson, the number is on the screen. If you want to join online lessons for mathematics 2024 GCE, the number is on the screen. You can use that one to call me so that you can join. 60 kwacha is the amount that I charge. All right. So thank you very much for watching. As for now, bye, and see you in the next lesson where we'll be looking at the pseudocode.